Okay, this question asks you to estimate the volume obtained by rotating about the y-axis the region under this curve, which that's this picture over here. And it looks like we need to rotate this around the y-axis. So g of x is the height of the shell, of a typical shell, and x is the distance from the axis of rotation to the center of a shell. And so this is the integral that we want to evaluate right here using cylindrical shells. 2 pi times the definite integral from 0 to 1 of average radius, height of the shell, width of the shell. Okay. And we're supposed to use n rectangles. This is actually, by the way, you can't really find an antiderivative for this function. So we have to use numerical methods. And you're supposed to use the midpoint rule. So the width of each subinterval is 1 minus 0. From 0 to 1 is the length of 1 divided by 5. So each subinterval is a length of 0.2. If you want to find the midpoint of that first interval, you just take the average of 0 and 0.2, which is 0.1. After that, you can just add 0.2 to get to the next midpoint, to get to the next midpoint, and so on. So these are the values of the midpoints of each subinterval. And the Riemann sum looks like this. 2 pi, that's from here. Delta x appears in each of the summations, so we can pull that out, which is the 1/5. And then we want to find the sum from I equals 1 to 5 of the value of this function at each midpoint. So m sub I, which these are the m sub i's from 1 to 5, times the square root of 2 plus 2 times m sub I cubed. Here's kind of what that looks like. With 1/5 put in for delta x. Here's the 0.1 put in for m sub I. Here's the 0.3 put in for m sub I. And then you'd have 3 more terms, 0.5, 0.7, 0.9 for m sub I. And here are the corresponding values for each of those m sub i's. If you substitute that in to f of x, add those all together, multiply by 2/5 pi, and you'll have the volume of that solid estimated. Here is an estimate using 5 rectangles, 5 midpoints, and here's the actual integral value, 5.227. So we're pretty close, off 3/100ths approximately. Okay, there you go. Hope that helped. If you have any questions, post a comment.